This is a super important topic. The likelihood of internal corrosion increases significantly when product flow rates decline. All sectors of the industry have just now entered into a period of increased susceptibility to internal corrosion damage. In addition to the increased corrosion risk attributed to the water film transport during periods of downturn, an increase in the on-off cycling of wells within the well fields, and a decline in the operational reliability of processing facilities also present substantial integrity threats to downstream pipelines. It is essential that production and pipeline companies make appropriate adjustments to their mitigation practices during periods of reduced pipeline utilization to prevent corrosion damage and to achieve long-term reliability. We consider the hydraulic data derived from mechanistic, fully compositional pipeline models in combination with our experience and deep understanding of corrosion mechanisms to create a realistic corrosion rate and corrosion damage profile for a range of potential operating conditions. Our QICDA engineering assessment methods are an evolution of the work pioneered by the Neocore engineering team that I led in the 1990s in collaboration with global leaders in the field of pipeline modeling and corrosion science. Because of our consistent ability to pinpoint locations of corrosion damage, our work was embedded as the foundation of the INGA Technical Subcommittee for Internal Corrosion in 2001-2002. The work of our committee evolved into the NACE ICDA standard for gas transmission and wet gas pipelines, although in a simplified form. This is an example of our QICDA Pipeline Integrity Management Plan. This first example is for a crude oil shipping pipeline constructed in 1965. The mitigation guidance recognizes how declining oil throughput rates, living in the red, contributes to oil water slippage and accumulation of stagnant water at the locations of pre-existing damage. In response, the mitigation guidance triggers batch inhibitor application between pigs during low flow periods to prevent growth of the pre-existing corrosion damage. Conversely, when the pipeline is operating at elevated oil shipping rates, the water travels at the same velocity as the oil, accumulation of water onto the bottom of the pipeline does not occur, and the threat of internal corrosion is eliminated. It is important for field teams to know if process upset conditions upstream of gas transmission pipelines are likely to cause corrosion damage or whether episodes of non-conforming operations are benign events. If the pipeline is operating in the green, the implication of upset conditions is much less than if the pipeline is operating within the red. Feedback from field teams has been universally positive over the past 25 years for this deliverable. They appreciate the ability to understand the implication of changing throughput to the corrosion potential and the opportunity to forecast the implication of change so that they can adapt their mitigation schedules to prevent corrosion damage. We would be thrilled to have the opportunity to speak with you online about how our QICDA project work can elevate your understanding of the integrity hazards your pipelines face during these critical times of reduced throughput, and how we can position your field teams to schedule appropriate mitigation to prevent corrosion damage and future failures. Thank you for watching this video post.